Okay. Well, I'm speaking today to Rick Thoman, who's an Arctic climate scientist at the University of Alaska in Fairbanks, and also a contributor to the latest Arctic report card. So, Rick, thank you so much for speaking with me today. I look forward to our conversation.
You bet. Thanks for having me, Tom.
So, if you could just, start by telling us a little bit about your own focus, what your research is.
So my work here with the Alaska Center for Climate Assessment and Policy at the University of Alaska really focuses on providing the translator function between climate science and the users of that information in Alaska. And I particularly focus on providing usable, actionable climate scale information to rural Alaska, especially Western Alaska, where climate change is occurring faster than just about anywhere else in the United States. And the communities there, nearly all are predominantly indigenous. And so they have a mixed cash subsistence economy. So they're very close to the land and very much aware of the changes that are occurring. And so I spend a lot of time providing that kind of outreach, that's providing information that they can use, that the communities say that they can use, as opposed to, here's some climate information, hope you find it useful,
Right.
kind of thing. So I spend quite a bit of time on doing that. And then I also contribute to various IARC projects in my role as Alaska climate specialist, and things like these national level type assessments as well. Again, in the past, I've focused again on what I know, which is Alaska and Arctic climate. To that, this year, a new role for me as one of the general editors for the Arctic report card.
And we'll get into a little bit about that in a minute. But first, can you give an example of the kind of science that indigenous populations and other residents of the Arctic and Alaska can use based on that translation and that you kind of were talking about? A concrete example.
Sure. So in the Bering Sea region, by far the most important winter variable that communities are interested in is sea ice. Temperatures are almost irrelevant. Precipitation almost irrelevant. What drives everything is, when's the ice going to get there? When's it going to be stable enough to work on? When's it going to go away? And those are the kinds of things that people want to know. There is information available within the science community, within NOAA, but it is very difficult to get to and work with if you don't know what you're looking for. Almost everywhere in rural Alaska has very poor internet connectivity. And so, for instance, for the sea ice piece, NOAA's Climate Prediction Center produces experimental weekly out to 6 weeks and seasonal out to nine months sea ice forecasts. No one, especially in the small communities in Western Alaska, has the connectivity or the hardware to go download the net CDF files, put them into graphics that they could then use. And so I spend a lot of time, it's not that this is new stuff, but it's getting it to people who otherwise couldn't get to it. They don't have the technological connections. The digital age, to some extent, has left rural Alaska behind. But cell phones are ubiquitous. And so if I can make the graphic in a way that the communities find useful and put it in a place that it's accessible on say, cell phones, then it becomes, hey, we've got some information that we can potentially work with.
And just to take it one step further, information about sea ice is vital for these communities because
for the coastal communities, sea ice is an extension of land when it's there. And so they're traveling on that ice, they're hunting on that ice because of the changes in sea ice, especially in the last 20 years. The traditional knowledge on how that ice works, when it's safe, when it's not, that's all changing. So much less ability to rely on that cultural knowledge that's been developed over the millennia. And so, so that's one example. Another would be, particularly this time of year and the late fall, early winter, there's a lot of anticipation for when the ice shows up, because it changes the entire routine of community life. Once the ice is there, then you can start doing the winter activities. Before the ice is there, and especially this time of year, which is the stormiest time of year in the Bering Sea, people are sitting around twiddling their thumbs for the most part. Okay, when's the ice going to show up? So, if I can say definitively, which increasingly we can, of course, in the fall, okay, the ice isn't going to show up for at least 2 weeks. That's information that people can use. Oh, maybe I should go to Nome to get my doctor's appointment that I've been waiting on, kind of thing. It's actionable information. The other thing that matters a lot in the science world, in Arctic science, we often are thinking about sea ice in the extent. What's the extent of the sea ice? That's actually the least important thing at the community level. It's there's ice or there's not. Doesn't matter if the edge is 300 miles to the south. What matters are things like the quality of the ice, the stability of the ice, on the North Slope, the age of the ice. Some of those things are extremely difficult to detect with remote sensing. The quality of the ice that's an on the ground, you have to be there to assess that. And for the Bering Sea communities, of course, they have generational cultural experience at assessing that kind of what quality of the ice is, and at least what historically that meant when you're using that as a platform for traveling and for hunting.
That raises an interesting question, and maybe we can circle back to it later, but it raises a question of knowledge that communities on the ground can provide in the other direction about what are things actually like right now, how are they been changing over time, in filling in gaps that things like remote sensing can't provide. And I know I saw a little mention, I think it must have been in the executive summary, that more of a focus on indigenous communities and perhaps involving them in that kind of work got delayed because of COVID, unfortunately.
Yeah, we had the first indigenous-led and focused essay in the 2019 Arctic Report Card. The Arctic Report Card editors, which I was not one in 2019, worked with the Bering Sea Elders Group and came up with this an essay that was important to emphasize. Wasn't just, okay, we got a bunch of elders in the same room and asked them some questions and wrote down the answers, but rather we did get them in the same room and they knew why they were there, but they picked, what do you want to talk about? What do you think that an international audience ought to know from your experience?
Right.
And it wound up being the editors. There's of course a lot of things that they could talk about. So the editor's job mostly there was to hone it in onto topics that could fit in one essay.
Right.
But that was really the editor's role, rather than here's what we want to talk about, give us your answers.
I mean, this is maybe a subject for another conversation, but there's easily a really interesting feature story there about that increasing role in that way. But if we go down that route, then we won't talk about some of the things that I wanted to make sure we've got to talk about today. So, but I'm gonna kind of make a note of that, because so much attention is always put on what's the latest sea ice extent by satellite this month, and yes, it's the second lowest minimum sea extent on record, and we write these things in our stories that say, has impacts on indigenous cultures, et cetera, but that's always sort of the secondary thing. It's always like, here's this thing that's happening on a big scale. And it strikes me that this sort of reversal now of, kind of going in the other direction from the local to the global is ever more important. So, note to myself, interesting story to focus on. I may be back in touch with you about that because you seem like you're the perfect person to talk about that.
I'd be happy to. Specifically about the 2019 Arctic Report Card essay, Matt Druckenmiller led that, and he's on your campus, I believe, these days.
And I will go back and read that. So I think it's a symptom of a blind spot. I think it's been a blind spot, probably for scientists, and certainly for journalists as well. That I think when I looked at the 2019 Arctic Report Card, my focus wasn't there.
Right.
It didn't stand out to me like, oh wow, you should read this first, because this is kind of really a new and important thing. So I'll go back and do that. I'm glad we talked.
Along with that project, Bering Sea Elders Group produced I think it's three separate videos. It's no more than 20 minutes, called After the Ice. Take the time and watch those.
That sounds familiar.
They were just released, I don't know, late summer publicly. They were shown at the rollout, I think, last year at AGU, but they only went on YouTube maybe August-ish timeframe till all the permissions were there. But if you haven't seen them, go watch them. They're
I
really fantastic.
I will do that. And just as an aside, are you aware of the Threshold podcast by any chance? Have you have heard of that?
No.
Look it up. It's also sort of very much in keeping with what we're talking about. And Threshold, and the person who is the spearhead and whose brainchild it was is someone named Amy Martin, who was part of our program for a year. And it's really terrific. So, and I think you in particular would be interested in it.
I'll check it out.
All right. So let's talk just a little bit about the Arctic Report Card, and then I had a few other questions that kind of pivot off that report. And so I guess the first one, you probably get this question from journalists all the time, and I don't know if it's annoying to you, but we're always interested in, what's maybe the most significant development this year? What's the thing that stands out for you the most? And maybe there isn't one thing, and that's fine, but I'm curious to hear your thoughts.
So as a climate person, what stood out for me from the physical science side as the oh wow, kind of the jaw dropper from the physical science side was both the persistence of the temperature anomalies in Siberia and the magnitude of those anomalies. In recent years have featured somewhere in the Arctic having month after month after month of these positive, this run of above normal temps. In 2019, it was Alaska and parts of Northwest Canada and Chukotka. This year, it's in Siberia. A couple years ago, it was Greenland. But the magnitude of the anomalies were so high in Siberia this year. The sustained magnitude of those departures was really quite amazing. Of course, that's complete. That is in no sense independent of the record early sea ice loss, of the huge wildfire season, the early loss of snowpack. Those are all interconnected. And that to me was much more surprising and jaw-dropping, if you will, than say the sea ice minimum, the second lowest, wasn't very far below the linear trend line. That was not surprising. So I think that from the physical science side, that was the most anomalous thing of kind of our annual update.
Right, and as with all these things, there's sort of like proximal causes. And then, of course, superimposed on a long-term trend of warming. What are some of the thoughts about what in particular was responsible for such an unusual and long-lasting warm temperatures in that region?
Well, I think probably going back to last winter and the very stable um, storm track pattern that in technical terms, very strongly positive Arctic oscillation,
Yep.
but not just strong, but stable. That's the thing. And it wound up oriented in relation to the pole such that Alaska and Western Canada were relatively cold, again, especially in the context of recent years. And Eurasia, given that stable configuration of the flow, was relatively warm. And I think that really set the stage, because once it was warm in the spring and the snowpack melted, and I think it's pointed out in the terrestrial snow cover essay, it wasn't because they had low snow. They had a decent snowpack going into the spring across Siberia. And it was so warm, it melted so early. And then that set off the cascading effects, exposing the land earlier. So the land starts to heat up earlier. Runoff starts earlier. So you've got discharge from the big Siberian rivers into the adjacent seas much earlier than normal. And so that a very strongly reinforcing pattern. And then the heat in the summer, the 100 degrees Fahrenheit at Verkhoyansk, of course, weather scale event, but emblematic of the summer. And then going into the fall, of course, when all this open water in especially the Laptev and East Siberian seas, all this open water that has historically been ice covered. So the anomalies by definition have to be huge in the fall because it can't be colder than minus 1.8 C because it's water, not ice.
Right.
So I think it's really, we can trace the heat back, at least to first order, to that very strong Arctic oscillation, very strong and very persistent.
And presumably, there's research that would, examine the impact of climate change on persistence of Arctic oscillation and et cetera, et cetera. But regardless of, whether we know that yet or not, we've had Arctic oscillation phenomena in the past. I'm sure it's been strong in the past, but now all of this is built on top of a long-term trend of warming. So the impacts that you get are that much more intense.
Exactly. And, at this point, we actually have no reason to think, doesn't mean there isn't one, but we have no reason to think that the Arctic oscillation that we saw last winter, very stable, very strong, is anything more than just random variation. But the background conditions on that random variation is working on now can produce these long-lasting repercussions through the climate system.
Right. Okay, great. Thank you for that. It's really, really interesting and unsettling at the same time. And so another question that kind of involves the report, maybe you've really touched on it, but or maybe you can add to it. What do you think is the most important takeaway message for just a kind of general audience? People who right now are probably really focused on COVID and politics and all these other things that are happening in the world. And so, the Arctic just seems like this really distant place that doesn't impact their lives. And of course, not to take away from those things that are happening, they're critically important, but nonetheless, there is these really dramatic things happening in the high north. Anything to say to those folks, a takeaway message, why they should care and pay attention?
Yeah, that's always a tough one. In the past, I have tried, for Americans, believe it or not, Alaska is part of the United States, and the peoples in the Bering Sea on the North Slope whose lives and livelihoods are being dramatically affected are Americans. So if you're in Georgia and you care about wildfires in California, you ought to care about these dramatic changes in Alaska, because they are negatively impacting Americans right now. Another tack that I would take, and I think this is especially, or this is something that's gaining importance for people at large outside of the Arctic, with the changes that we're seeing in the Arctic, especially sea ice. This year we had more traffic across the northern sea route by quite a lot than we've ever seen before. 2 weeks ago, we had 900-foot Russian, those liquid natural gas tankers going through the Bering Strait, both north and south, in early December.
Wow.
Utterly unthinkable even 10 years ago.
And did they come across the northern sea route above
Yes.
Syria?
Yeah, they're coming from the natural gas processing facility on the Yamal Peninsula.
In December?
In December, going both directions.
Oh my goodness.
Both returning. These are going to ports in Korea and China. And one of these tankers was going back to the Yamal Peninsula, and another one was coming from there in the first week in December.
My.
And that would have been unthinkable 10 years ago. By definition, if they're going through the Bering Strait, they're coming within a few miles of U.S. territory. So, that's both an industrial issue. It's a rights of the sea issue. It's a national security issue. So even if you're far from the Arctic, and if you're an American, your country is going to be involved in that. We've got what's the name of the icebreaker that usually goes to Antarctica this time of year, but is now going to be in the Arctic. That's not because they couldn't go to Antarctica. There's a reason that
U.S. icebreaker you're talking about?
Yeah.
Is it the Healy?
No, it's not the Healy. I'll think of it here.
Yeah, it's okay. It doesn't matter. I can look it up.
But that's being sent here for a reason, and it isn't because they can't go to Antarctica.
Yes.
So there's the whole national security issue. When there's some major accident, oil spill, ship capsizes, going through the Bering Sea in December is not risk-free by any means. The U.S. is going to have to respond to that with the changes that we've seen in the Bering Sea to fisheries, for example, with southern fish moving north. Just to the west of the international dateline, there were multiple foreign, probably mostly Korean and Russian, fish processor ships operating just west of the dateline to the end of November.
Wow.
Again, utterly unthinkable even 15 years ago. And these are giant ships, and they're not going to be there unless it's profitable to be there. They're catching fish, processing fish, because the fish are there. And these are fish that weren't historically there at that time of year in the past. So it's going to affect the national scale or international scale economies, whether it's fisheries, whether it's industrial transportation. We didn't see it this year because of COVID, but of course, that the tourist industry, the maritime tourist industry, is also increasing in the north. The farthest north right now, the farthest north U.S. Coast Guard base is in Kodiak, 700 miles from Arctic waters. There are no communities bigger than about 4,500 people on the entire Bering Sea North Slope coast. If there were ever to be a accident, or even not necessarily fatal, but say one of these luxury cruise lines carrying 1,000 people loses power, how do you get 1,000 people, many of them older, off of that ship to towns that have no accommodations for anything close to that many people.
Wow.
For any individual trip, that's of course unlikely. But over, you just start doing these hundreds of these a year, sooner or later, there's going to be a problem. And we, Alaska, we, the United States, don't have the facilities to work with that right now.
So, that's an interesting segue to a question that I kind of ran by you by email, and then we agreed we'd talk about it this way. But the Arctic was once referred to as the canary in the coal mine. It's been known for a long time that as climate would change under the influence of humans, that the Arctic would probably start to show changes more intensely than anywhere else. It sounds like, I know you to tell me whether I'm on the wrong track here with this metaphor, but the canary's been chirping really loudly. Some countries have been paying close attention, and in some ways, the Russians taking advantage of it for economic purposes, and other countries maybe have not as much. My sense is that the United States maybe is a bit late to the game in understanding exactly what the ramifications of change are in this vast region of the planet where 4 million people live. Any thoughts about that?
So the canary is chirping, or if you prefer, of course, the original source, my understanding is the original source of that saying is miners took birds into the mines, and if they died,
yes,
then there was gas
right.
that they needed to get out. Well, if we extend that, the canary in the Arctic has died, and it's not a question of when will we see change. It's the changes are here, unequivocally. And as we state in the report card, the transformation to a wholly different Arctic than our grandparents or great grandparents knew is fully underway, and it will continue to change. I kind of resist the language about new normal, because there's no reason to think that in 30 years, much of anything in the Arctic is going to look like it is today. The Arctic is in a transition, and there's absolutely no reason to think that isn't going to continue. So 30 years from now, the Arctic is going to look quite different than it does today, which is quite different than what it looked like 30 years ago.
Right. I mean, maybe 30 years from now, we'll be having North Pole traffic, even shorter distance than what these Russian gas tankers were experiencing.
That's entirely possible. And of course, sometimes you hear people talk about an ice-free Arctic, and most people, if you're not working in the region, ice-free Arctic doesn't really mean zero. There'll be some ice persist along the northern Canadian islands and north of Greenland for a very long time. I define the ice-free Arctic as when you can take your sailboat and go from Utqiagvik, Alaska to Svalbard in your sailboat. That's an open Arctic. And in that you cross the pole.
Wait, didn't the famous Arctic explorer do that through the Northwest Passage? Okay, never mind. That was what, a 2 or 3 year journey? I can't remember.
Yeah, the Fromm. Yeah.
Well, no, that was. Why am I? Well, let's pass over that.
Okay.
My aging brain is failing to come up with the name, even though I've read multiple books about him. But we'll come back to that at some other point. So, and then that kind of leads, interestingly, also to news, that happened just yesterday, which is that the Norwegian Supreme Court ruled against an effort to stop drilling for oil and natural gas in Arctic waters in Norway. The case was brought on the grounds of a constitutional provision in the Norwegian constitution involving the environment, and they turned it away. And the details of that are interesting, and I can get into it in a story at some point. But you know, activists in Norway and elsewhere are, of course, disappointed by this because they say, you know, we need to really move away from fossil fuels now. We can't wait. We really cannot be opening new areas for exploration for fossil fuels. The Norwegian government and other governments as well that are taking advantage in this sort of paradoxical way of the opening of the Arctic to drill for more of these resources. The Norwegian government says, well, we know how to do this. We have a good track record. We're going to need these fuels for the foreseeable future. And so who would you like to have, you know, do it? If somebody's going to do it, shouldn't it be us? From a scientific perspective, I guess, because I mean, this question is in some ways is leading in a political direction, but from a scientific perspective, where maybe you might feel most comfortable, you know, what's your reaction to this continued push to drill for more fossil fuels in the Arctic?
So for that, I think I'll say obviously, world oil supply is not my expertise. And obviously, I mean, just as a citizen of the world, national interests or corporate interests, they're often diverge from planetary scale interest. And that's the world we live in. Certainly there is the as you called it, the paradox there of a more accessible Arctic, potentially at least, makes it easier to continue down the track that we've been since there's more surface area amenable to this kind of thing. It's still not easy in the sense that seasonal sea ice cover is actually very difficult to work with, where part of the year you've got ice, nowadays increasingly mobile ice, and part of the year open. And that's a very difficult environment to work on, much more difficult than, say, as in Alaska, oil companies have been exploiting for years. Stable shore-fast ice, it is really just an extension for land, and you can, when that shore-fast ice is stable for 8 months a year, you can do a lot of industrial work on that, as opposed to the same area, maybe the ice cover on an extent chart looks the same, but when that's not shore-fast, when that's not as thick, when it's mobile, that's a much more difficult environment to do extractive industries on. So it is certainly a mixed bag, and will remain as long as areas have seasonal ice cover. But the global scale effect is obviously to allow more of that kind of thing, and that's not what we need at the global scale and at the long-term view.
Okay. I think that's a good answer, and maybe that's a good place to end it, unless there's something that you think is really important to bring up before we close it out.
I think maybe I could emphasize more, and you kind of brought this up early on the sea ice question, is the focus is on, a lot of the press focus is on what's the sea ice minimum. And that has its place. But for many activities, whether it's industrial shipping or it's subsistence hunting or subsistence reindeer herding, most of the impacts from that changing ice is not due to how little it gets on a day in September, but it's the change in the seasonality of the ice. We have many examples in recent years. Prior to this year, we had gone several years with comparatively high in the modern era ice, above the linear trend line. But the seasonality of the sea ice loss near the most coasts was still way early, and that allows things like industrial shipping. It impacts the timing of hunting. So I think it's really important. The story isn't mostly, in my opinion, about the sea ice minimum. It's all the things that come with that. The seasonality of the ice near the coast, the changing thickness of the ice, the kinds of ice. It used to be back in the day here in Alaska. So like at Utqiagvik, the northernmost community in the state, it was normal, if you will. One night in September, October, you go to bed, open ocean. Get up the next morning, ice as far as you could see.
Huh.
Ice wasn't forming, of course. It was the pack ice coming in.
Man.
And nowadays, that doesn't happen. Now you have to form the ice in place. So even though, we had ice on this date back then and we have ice now, it's completely different ice.
Huh.
In English, we only have one word for ice. That's not the case in languages spoken pan-arctically, where there's many terms for any cultures that the sea ice is important for. So we're somewhat handicapped in English, but it's the changes in the other parts of the sea ice system, if you will, that are highly, highly impactful.
Okay. Well, I thank you so much for that. And so I'm going to stop recording, and then we'll just kind of finish up.